So you have to select a suitable flat belt for horizontal drive for a compressor. So we have electric motor having a power of 6.5 kilowatt, and it's running at a speed of 1500 rpm. And this motor is driving the compressor. And we say this compressor should have some pulley. That's a way of transmission. That pulley speed, it's I mean the rpm, the rate of speed of that pulley, compressor pulley is 500 rpm, and the service factor is given, and slip is also given, working stress is also given. So you have to design or select a suitable flat weld based on this condition. So these are all the given condition. I already written that. Apart from the all given condition, one thing we have to assume not to solve this problem is the density of the material. Okay, so I have to assume density to be 1000 kilogram per meter cube. You'll need that later. I will tell that part, but you have to assume density to be 1000 kilogram per meter cube. So first thing, not the solving step in solving the designing of flat pool, you have to find the diameter of the driver. Okay, here the driver is motor. So this equation will be using to solve the problem. So you can see we know all the parameters. Simple substitution, get the values. This is 17.9 mm. Okay, but you cannot take that value. That's not the standard diameter of pulley. You can find the standard diameter of the pulley in data book. So the next standard diameter will come, that will be 24 mm. Okay, so that is the standard diameter of the driver. Next thing, we have to find the diameter of the driven pulley. That can be found out by this equation. This capital D is equal to 1 minus epsilon D into I. This epsilon is a slip factor, or slip, not slip factor, slip. It's also given in the question as 2.5 percentage. So you have to convert, 2.5 by 100. You cannot write it by percentage. You have to convert by dividing by 100. That will be 0.025. And we don't know the value of I, but we know the RPM of both driver and driven. So not to find I, it's always the RPM of driver to that of driven. So here driver is motor, which is always having higher RPM. So 1500 by 500, you get the value of IS3. The small d is the diameter of driver. We know that value. So simple substitution, get the diameter of the driven pulley as 655.2 mm. We know it's also not the standard value. You can only proceed with the standard diameter of the driven pulley. So the next standard diameter, uh, based on the, you can find that in data book. The standard diameter will be 710 mm. Okay, so next parameter you need to find is the center distance. It can be find out by this equation 2 into d plus d. Okay, we know both the d, the diameter of the driver and driven. So substituting, get the value of center distance. Okay, next parameter we need to find the belt speed. This equation of the belt speed. Belt speed depends on the driver. Okay, you have to keep that in mind. So this will be the equation by d n by 60 into 1 minus epsilon. So d, diameter, and rpm are that of the driver. Okay, and epsilon, we know that's slip. Here one thing you have to look, uh, not avoid mistake, is the diameter has to be converted into meter. Okay, this belt speed has to be given this SI only, that is meter per second. You only know the diameter in mm, so this 224 has to be converted into meter. So that's why 10 raised to minus 3 is put here. So the belt speed, you will get it in meter per second. That will be 17.15. Next, you have to find the coefficient of friction. This is for based on Barth equation. You can find that also in data book. This V is the velocity of the belt speed, which you just found out. So the coefficient of friction will be 0.50. Next, length of the belt. They haven't mentioned whether it is open belt or closed belt. If nothing has mentioned, you have to take it by default as open belt. So this is the equation of open belt. We know all the parameters: c, center distance. We know the capital D, small d, all that thing. So simple substitution will get the length of the open belt as 5.2 meter. Next is the angle of contact. So there is angle of contact for small pulley and larger pulley. One for the from the motor and one from the compressor. There will be one small and larger pulley. So you need to find both theta s and theta l. But you only proceed. Not to solve the numeric. You only proceed with the smaller value. So among these, the small values for a smaller pulley, that is 2.88 radian. So that will be the value we'll be using uh, not to solve the next step. I will show you that. So next thing we have to find is the width of the belt. So whenever we want to find width of the belt, this will be the equation we'll be using. Here the PD is not the power that is given in the question. This is the design power. Okay, now how do you find design power is based on this equation. The given power in the question has to be multiplied with the slip factor CS. Only then you get the design power, that will be 7.8 kilowatt, not the power that is given in the question. So don't make that mistake. We know that's the belt speed. We know that value. This design stress sigma d is already given in the question. One value I already told earlier that to assume density. Okay, I already told that to assume to be 1000 kilogram per meter cube, but we know W is equal to rho g, so rho will be W by g. Here we already have W by g in the equation, so that can be replaced by density. So this density is W by g can be replaced by 1000. Here you can see the mu theta value. Already told mu is same for both the smaller pulley and larger pulley, but theta we have both theta L and theta S. Okay, smaller, larger, but you only proceed with the smaller value. That means 2.88 radian. So that will be here actually there is a mistake. Is actually 2.88 into zero point 0.5 is also there. Okay, so I made that mistake. So this mu is we know 0.5, so 0.5 into 2.88 is here. Okay, so maybe the answer will be wrong, but you have to correct that. Mu will be 0.5, theta is 2.8, so here 0.5 into 2.8, and here also 0.5 into 2.8, so maybe the answer will vary slightly. So BT will be around 243.75 mm. Okay, now I have the value of BT. So thickness in flat belt is found out by the equation 0.02 into diameter of the driver. So that will be around 5 mm. T value thickness. So we know the value BT. Now we know the value T. You can find the width of the belt. So even though 48.75 mm is the width of the belt, the next standard value according to data book is 44 mm. Okay, so we have to check that. Next, we have to determine the tensions in the belt. So the first equation can be found by using this equation, the power equation. We'll get the relation T1 minus T2 as this value. That will be a um, linear equation. Then we know this equation. This all are in the data book. We know this equation where Tc is centrifugal tension that can be find out by the equation. Here also W by G can be replaced by 1000. We know the value of Bt, we know V. So substituting the centrifugal tension, Tc will be 71.69. Okay. Then so again substituting into the equation, we get another relation between T1 and T2, linear relation. So we have two linear relation equation having variable T1 and T2. By solving that, we get the value of tension T1 and T2 of the belt as this much value. The last thing we have to determine is the initial tension called T0. This equation is also in the data book. We know T1 and T2. From that T0, the initial tension can be found out by this equation.